everyone, and welcome to Playground Global's RoboChat series, where today we'll discuss artificial intelligence with the one and only Gary Marcus. I'm Allison Braley, and I'm an operating partner at Playground Global, where I focus on marketing. For those of you who are new to our community, Playground Global is an early-stage venture capital firm that focuses on emerging tech. We're proud to support transformative companies like Robust.AI and founders that are making a multi-generational impact. Playground is an 80,000 square foot facility with various labs and a community in the building that's always excited to engage on topics like this one. So whether you're working from your fancy home office or your garage, as I actually am, let's all pretend we're at Playground, enjoying each other's company, and hope for more in-person engagement in 2021. We host RoboChats and other events at least quarterly here at Playground to discuss emerging technologies, company building, and other important subjects. So please look out for our next invitation, as we hope to see you there, albeit virtually for now. So with no further ado, let me introduce our moderator, Sasha Ostoyich, who is an operating partner at Playground and the mastermind behind these RoboChats. For those of you who don't know him, he's had an outstanding career, leading engineering for companies like NVIDIA, Cruise Automation, which is now part of GM. And he advises companies in our portfolio on engineering, technology, product development, and network expansion, and sits on advisory boards for companies like Zoox, which is now part of Amazon, Samsung, and others. He's joined by the legendary Gary Marcus, who is founder and CEO of Robust.AI, as well as a professor, author, and outspoken critic of AI as it exists today. We're absolutely honored to have Gary with us today and as part of our portfolio. And so with that, I'll turn it over to Sasha.
Hey, thank you very much, Allison, for that kind and excellent introduction. So before we start, some housekeeping first. Please keep in mind this session is being recorded, and we will publish the link to the recording that you can view at your own pleasure later. Q&A, please use the Q&A feature of the webinar in Zoom, and we will try to get to as many questions as we can. Feel free to ask the questions in the context of the discussion, and I will try to insert them as part of talking to Gary. And then lastly, please follow us on Twitter with the hashtag RoboChat. All right. Next, before we dive into our conversation, I just want to give a shout out to the mechatronics engineering high school students with the Silicon Valley Career Technology Education. I hope I got that all right. We really like it when high school students join, and I hope you will be inspired to do amazing things in the next decade based on what we discuss in this RoboChat and future RoboChats. All right, Gary, Allison already said all the great things about you, so I'm not going to repeat them. You are one of the founders of Robust.AI, in addition to Rod Brooks, Anthony Jules, Mohammed Amer, and all the engineers you put together on your team so far. And the goal of your company is to create the world's first industrial-grade cognitive platform for robots. So hopefully you'll be able to tell us a little bit about what that is. And I just have to say personally, it's humbling and thrilling to work shoulder to shoulder to your team at the Playground space. That's one of the huge benefits that we provide to our portfolio companies, and I'm really happy to have you guys co-located with us. So welcome, Gary.
Thanks very much for having me. Of course, it's been great having a supportive Playground on our journey as we build this industrial-grade cognitive platform.
Excellent. All right. So we're obviously going to discuss current state and the future of AI. You know, you are outspoken there. And what I really like about, somebody once said about you, you are contrarian, but not a pessimist, which is really great. I think any new technology development needs a voice like that to at least test the hypothesis and, push the field in the right direction. So given that you're a prolific author and you've published multiple books, papers in leading journals, your two books, Kluge and Rebooting AI, are about a decade apart. Kluge was about the limits of the human mind. Rebooting AI is about the limits of the machine. Tell us about that journey from human limits to machine limits.
Somebody sent me a cartoon this morning. It's actually from 1993. It's a Calvin and Hobbes cartoon. It says, once machines are able to think, what's going to be left? Left to program or to do, and humans can have mental illness or be irrational or something like that. And I was thinking about the cartoon, and not a lot has changed since 1993 in terms of computers not being able to think. But I've kind of looked at it from both angles. So the book that I wrote in 2008 called Kluge, Kluge is an old engineer's term for a haphazard solution, duct tape and rubber bands, something that manages to get something done, but it's not pretty. And the thesis of that book is that the human mind is a kludge. And then, last year with Ernest Davis, I wrote this book called Rebooting AI. And a lot of the punchline of the book is we should really look to humans so we can make our AI better. So it might feel like a contradiction, but I think the right way to think about it is something that I arrived at in a panel with Danny Kahneman, the Nobel laureate, which is, I'm not sure which of us came up with the phrase, or maybe we came up with it together, but it's that humans are a low bar, but we still haven't exceeded it with machines. So, it is perfectly possible to envision a machine that could think in a more rational way than human beings, in a more reliable way. We already have machines that can do certain things better than humans, like arithmetic, much better than humans. But there is something that humans can do much better, which is to understand ordinary language and understand the world in kind of everyday kind of way. We're not perfect, we're subject to optical illusions and things like that, but we pretty much understand how the world works and we can reason about it. We don't have robots that are the same way, where I could just take a robot off the shelf and say, hey, go tidy the room for me. And it would understand what you mean by tidy the room, and it would understand that you shouldn't cut up the furniture and put it in the closet, because even though that would look tidier, I would be sad because you cut up my expensive custom couch. We don't have machines that understand that, whereas an ordinary housekeeper would understand that perfectly well. So there's this whole set of things that people do badly. I think fundamentally we could go into this because of limitations on our memory. So for example, because we can't reliably search our memory, we wind up with confirmation bias. We find kind of the first thing that supports our theory, and we're like, yeah, I'm right. You should believe in my political party because I've got some evidence for it. We're not very systematic about it. Machines could be much more systematic, but they don't have the causal understanding to understand any of the stuff that's stored in their memory. And so, both systems actually have a long way to go. People could be a lot better. Critical thinking education could be much better. And at the same time, machines could have a much better causal understanding of the world and how we use language. So, the design spec for both leaves something to be desired, and over time will make it better.
Yeah, so you've immediately hit on kind of the limitations of AI, but if you ask the average person on the street, or even some researchers, the perception is that the AI is way more capable than it really is. And the concept you talk about in Rebooting AI is the AI chasm. So let's dive into that.
So the AI chasm was a way of talking about a few different things, but the difference between where we are and where we want to get, and also where we think we are and where we actually are. And one of the examples that we used in discussion there was ELIZA, which is from 1965 or 66. And ELIZA was a psychotherapist that was basically just doing keyword matching. And in very short bursts, it was convincing. And some people had whole conversations. They were basically text messaging over teletype with this machine. And people thought, because it would ask questions like, you'd say, I'm having trouble with my girlfriend. It would say, well, can you tell me more about your family? And so the keywords would be like girlfriend and family. And it would be persuasive to people, which proves the old P.T. Barnum about you can fool all of the people some of the time. It's not that hard to fool a human being into thinking that another agent is a person, because our brains have been evolved to quickly tell the difference between people and, say, other animals. And so, it's a bit of a just so story, but I think it's roughly right that we take small amounts of data to indicate, hey, this is another human being that probably think roughly like me. And then we do that with machines. And so you do that with ELIZA, and you end up thinking, because this thing could put together a few words and ask you about your family, that it must be, like a human being. I mean, obviously it's not like a cat, because a cat's not going to ask you that, but there's this whole other category that we didn't evolve to deal with of machines, and most people don't know how to think about them. So that was 1965. That's a long time ago. It was before I was born. But fast forward to this year, we have this thing called GPT-3, and we're seeing the ELIZA effect all over again. This is an example of the AI chasm. People see some illustration that looks impressive, and they're like, there must be some intelligence there. I saw a whole bunch of tweets about, well, my guess about how far genuine artificial general intelligence is went way down when I saw what the system could do. But the reality is all the system does is it predicts what comes next. It does a really good job of predicting what's coming next, but it doesn't really have any conceptual understanding of the world. So I wrote a paper for Tech Review that I think you know about, that was supposed to be called GPT-3 Bullshit Artist. The editors didn't let us call it that, but that's what you and I can know it was supposed to be called that. And the point is, like, a bullshit artist puts together a lot of different stuff and tries to make it sound like they know what they're talking about. And GPT-3 kind of does that. It doesn't have the motivation, but that's just how it works, is it puts together the most similar thing it can find essentially in a context. And sometimes it works and sometimes it doesn't. And it's pretty easy to break it. And I got very limited access because OpenAI didn't want me to touch it. I asked them when, all the way to the top, and they said no. They said someday.
It doesn't sound open.
Yeah, well, that's a whole other thing we can talk about. It clearly at this point, they have pivoted 180 degrees from their original mission of being open to being closed and corporate and so forth. But and they're still a nonprofit. Part of it's still a nonprofit, and that's an interesting question. But putting all of that aside, it's easy to break the system. So we had an example like I have some grape juice I have some cranberry juice. I'm really thirsty. I pour in some cranberry juice. I can't smell it, and then the system has to fill out what's going next. And it goes from I can't smell it to I drank some and I died. Well, you're not really going to die drinking cranberry juice, at least under any ordinary circumstance. An ordinary human understands that. In fact, Ocean Spray sells a drink that is cranberry juice and grape juice, commercially mixed, and people buy it and they don't die. But the system is not looking for causal relations between the chemistry of the different drinks and human physiology, or even some intuitive version of that. It's just noticing I can't smell it is correlated in this huge database with I drank it and I died. So it's looking at the words and how they correlate rather than the concepts and what they mean. So in fact, it couldn't be, in my view, further from intelligence, but because it can, for many sentences individually, seem as if it's human, because it's basically cutting and pasting human utterances together. It's a little fancier than that, but that gives you the idea. By cutting and pasting those human utterances together, it seems to someone who's not an expert like it's almost like a person. The reality is it's nothing like a person, doesn't have any of the underlying scientific knowledge, it doesn't understand anything about moral reasoning, legal reasoning, physical reasoning, psychological reasoning. If we really want to get to AI that we can trust, we need all of those things. We're going to need our robots and our agents to be able to do physical reasoning, psychological reasoning, and so forth. GPT isn't an advance towards that at all, but if you're not trained as a psychologist to understand and interrogate a system, it can seem as if it was. So that's part of what the AI chasm is about. And part of it is just like the distance between where we are now and the kind of parlor tricks we can do and where we want to get to having machines that, for example, can, let's say, take care of your mother in her home and keep her from having to go to a retirement community. The gap is just enormous. And part of the book is about what do we need to think about in order to solve that.
All right. So you brought up OpenAI and GPT-3. I'm glad we went there. Kind of to play devil's advocate, they're arguably trying to move the field forward, improve AI, do the right thing, develop things that have utility. They signed a deal with Microsoft to use GPT-3. A big British newspaper wrote an editorial using GPT-3. We can touch on that. So my question is, why are you so unpleasant to them?
Well, I mean, there's a couple things. One is I really resent that they're still a nonprofit and yet they're kind of running a marketing scheme. And in fact, the whole representation is that they are open. That's the name. But the name no longer indicates the truth. So I'm particularly unpleasant because when I said, can I try out your system in my scientist hat, they said no. And that sort of boggled my mind. And then I started reading up and saw that they're still filing nonprofit returns. They're still shielding things from taxes. And the premise of the whole organization was basically to save us from DeepMind. The notion was, DeepMind is this big corporate entity that is going to keep its AI to itself and not share it and do nefarious things with it. And then they said, fast forward a couple of years later, they say, we have this technology that's possibly dangerous to use. Well, the original premise is if you have something that's dangerous to use, you should shine some light on it so the community can deal with it. And instead they said, no, we're not going to share it. And not only that, we're going to charge for it. And we're going to sign an exclusive license with Microsoft to do it. And so they're doing exactly the thing that they were set up to avoid, still taking the nonprofit protection that was supposed to be for that thing. There's also a for-profit now, but the supervision there doesn't seem to me to be appropriate. And I don't like that. If they would just change their name to Closed AI and stop taking the nonprofit exemption, then I'd say they're just another company. Then the question would be, do I approve of their research program? And I would say I would do it differently, that most of what they've been doing is building huge data sets and scaling them, and they're good at that. But I think we need some foundational research on things like causal representations and so forth that I don't think that they're doing. I think that using the big databases is a crutch. And one way to think about that is little children learn a lot about the world very quickly with much smaller amounts of data. I think that's partly because they have innate representations of objects and places and people and so forth. There's a lot that they have to learn, but they have some kind of core there. That's what I think AI research, foundational research, should really be about, is trying to build those things in, and not, hey, what happens if we add 2 orders of magnitude more? And never mind like all the power consumption and carbon issues. Is a question about, is there even enough data to even pursue that? And my view is it's just not the most profitable research direction. I prefer a place like DeepMind that is much broader, I think, in the kinds of approaches that it takes.
Yeah, so let's talk about the sheer size of these models. I don't want to pick on GPT-3, but they are leading with 175 billion parameters, just how big it is and how much GPU time and the power budget of a small country takes to train a model like this and then sustain it. But even an average model, there are some studies out there that say, take roughly the carbon footprint of 2 American average adults over 2 years to just train an average model. And then, you touched on the diminishing returns of as you keep adding data. What is the solution there?
I mean, I think we're going to have to approach AI in a different way. I will say, look, if it took that much power once, and we really solved the AI or AGI, we produced a general system that could work on climate change and help us figure out COVID faster and so forth, I'd say fine, right? The problem is, it's like every single task requires a different giant data set, and none of them do you really get the reliability and robustness that I think you need. So it's fine for autocomplete. Like, you could make the world's best autocomplete system, but I'm not sure the world's best autocomplete system justifies the amount of energy consumption. In any case, I don't see it as on a path to getting us to the more robust AI that I really care about. And in context of the company, that's robust AI for robotics, but that's also writ large, not just the company. It's how to make AI robust enough so that, for example, AI could read the medical literature and help us understand something like COVID faster, or help us anticipate that something is down the road, that this one really is going to be the dangerous one, and we need to put in all efforts, and we need to lock down right away because this is the serious one, whereas Ebola is not going to spread as fast. I mean, you can imagine AI systems doing that kind of thing. That's what AI, I think, was originally envisioned to do, is to be kind of like the Star Trek computer and help us solve hard problems that we can't solve on our own. It wasn't built to do autocomplete.
Yeah,
built to help us with science and technology.
Yeah, so you brought up COVID. You tweeted about this. It's a wake-up call for AI. What kind of problems to focus on instead of ad tech and recommendations and toys? Gary Kasparov also tweeted at you and said, this is where the world needs to focus their attention instead of the uninteresting easy stuff, I guess.
Yeah, exactly. I mean, some of the easy stuff is interesting at some level, but I'm not sure it's meaningful in terms of, you want to live a meaningful life and help leave the planet a better place than you saw it. And ad tech doesn't leave the planet, I think, a better place than when we got here. And I think, in fact, there's been a lot of dangers that have come out of ad tech in terms of, like, Facebook, I think, has polarized politics and things like that. So I don't think ad tech has been great for us on the whole. There's obviously a lot of money to be made there. And I think there's a chance for AI to fundamentally help the world, and that opportunity has not been taken. So on the one hand, you have ad tech, and there's all kinds of problems with bias. Like, I'm not sure that the net impact of AI so far has been all that positive. You mentioned before, am I an optimist? Am I a pessimist? I'm a contrarian. I am long-term optimistic and short-term pessimistic. So in the short term, I don't like what I have seen all that much with AI. I don't think it's really helped us anywhere near as much as it could. In the long term, I'm optimistic. I think we can build a better AI that we use to help us with climate change and help us with biological problems like COVID and so forth. But I think that necessitates a shift in our priorities. So, I mean, we're doing it robust as we're trying to figure out how to make robots more helpful to people. So, like, it would be great if in eldercare environments, we had robots that did not transmit disease internally and could really take care of people. And the software foundations for that just don't exist, and we're trying to build that. So in our way, we're trying to help build robots that work in three-dimensional worlds that are trying to help people in a way that just, I don't think exists yet.
So in the context of COVID and AI in healthcare, so 2 things come to mind. Jeff Hinton 5 years ago said, 5 years from now, we will not need radiologists. AI is going to interpret all medical imaging. Hasn't happened yet. The recent recipient of the $1 million AI award, I forget her name, the MIT professor.
Regina Barnsley.
Yes. She specifically talked about her experience in wanting to do good in healthcare with AI, but she could not get at the data. So it's not necessarily a research problem. It's a more structural and problem that involves government, institutions, and so forth.
There's many, many different facets to it. So on the one hand, I think the AI techniques we have are not really good enough yet. So they tend to be about pattern recognition in an ordinary regime. So the things that we have are good at classifying, deep learning in particular, is good at classifying things as long as the kind of assumptions under which the data were collected were correct. But sometimes like the assumptions can be about like a particular lighting condition. So if you gather your radiology in slightly different circumstances, the thing might not work. So there's some technical problems that haven't really been solved. Then there's in terms of Hinton's kind of fantasy that will replace radiologists, there's a breadth of things that actual radiologists do that's not captured by the mechanism. So actual radiologists read your chart and try to relate the set of symptoms that are observed to what's in the image. They don't just look at the picture and sort of say, this is an X, this is a Y. At least some proportion of the time, they're more like Sherlock Holmes trying to put together the clues. They're like, well, this is asymmetrical, and what could that mean that this is asymmetrical? And that level of reasoning eludes current AI. So there's those set of problems. Then there are lots of problems around data. So like hospitals not wanting to share with one another. And then there are economic problems in terms of insurers not wanting to pay for certain kinds of things and so forth. So it's very hard doing AI for medicine. It's something I'm pretty interested in and would like to help with at some point, but it's much more difficult than it's sort of imagined. So I mean, going with Hinton's thing saying that, in 5 years, this was 2015, we won't need radiologists anymore. So there are 400 startups now working on it and 0 actual radiologists replaced because it's hard. There's a lot of different things that have to fall in line. And I do think, again, long-term optimist, I think eventually we will in fact replace radiologists. We'll allow, you'll be able to use your cell phone to do things that we can't even imagine now that will help parts of the world where there aren't enough radiologists and so forth. So like long-term, I think this stuff is going to be great. Short-term, we have to be realistic about the limits of the architectures that we have, and for that matter, the data behind them and so forth.
All right, you mentioned robust several times. There are a lot of questions coming in from our audience about, they would like to learn more about robust. For example, Cynthia Young asks, what industries or applications is robust most interested in tackling? Vladimir Prelovac asks, what will the V1 of robust product look like? What can you share there? Inquiring minds are really interested.
I can share more about the long term than the short term. The long-term vision is this is going to be a platform that you can use in whatever vertical you want. And the analogy is like a game engine. So you've got an artistic vision for a game and you don't want to sit there wasting all of your time coding collision detection and ray tracing and so forth. So you use something like Unity or Unreal, and then you can get to the thing you care about faster. And so what we're trying to do is to build an engine. So whatever it is that you want to do in robotics, you can get there faster. Now, we're not necessarily working in pick and place in an assembly line. A lot of people are doing that kind of thing. But we're more thinking about in unstructured and open-ended environments. Let's say you want to do package delivery to the door, or let's say that you want to do elder care in the home, or let's say you want to work on construction sites, or let's say you need to navigate hospitals or schools or whatever. All of that should be easier. Our system should help your robots understand where they are, cope with emergencies, cope with unexpected circumstances, be safe, and be transparent and unobtrusive. So they should do what they do without bothering you, without keeping you from doing what you want to do in your day. So in the short term, we're working on a couple of partnerships. It's a little bit too early for me to announce. But in each partnership that we're going after, we're trying to build part of this fairly ambitious platform and help somebody in a real world problem. And so if that appeals to people, we're having conversations. We have a couple things going, and we will add more and more over the next several years.
All right, so let's get back to the future and talk about the next decade in AI. You wrote a really excellent paper on this, and you gave your thoughts about it, where you concluded basically the current paradigm, long on data, but short on knowledge, reasoning, and cognitive models, simply isn't going to get us to the AI we can trust. And there are some questions from PhD students basically asking, what should I work on? What are promising areas of research? So let's talk about that.
So I think one thing to work on, especially if you're in basic research, is how do you blend the world of deep learning, which is good at learning from massive amounts of data, with the world of knowledge. So you don't really want to learn everything from data. For one thing, data can be expensive. For another thing, it can be unreliable. Sometimes it can be unobtainable. In another article I did with Ernest Davis, we had a picture of a robot on a tree limb with a chainsaw cutting down the wrong side, cutting from the wrong side, such that if it made the cut, the robot was going to fall out of the tree. You don't want to have 100 million trials of robots doing reinforcement learning, cutting down the wrong sides of trees, right? The data there are expensive because somebody might die or your robot's going to get destroyed or both. There are lots of places where we don't want to be so dependent on data. Well, how do you do that? Well, you have to let people or something teach you. And there's actually a lot of knowledge out there in the form of Wikipedia, and you can just go and talk to people, right? This is what humans do, right? We get some data from the world. We do a lot of experimentation and interaction. We also learn things. We go to class, or our parents teach us things. We read. And the point at which we can get knowledge, let's say from a Wikipedia page, and put that together with the kind of stuff we can get from, let's say, supervised learning, pictures and labels and stuff like that, that's going to be a major advance. So if you really want to do foundational research, I think that's one place to do it, is this intersection between knowledge and kind of learning from large, or at least from moderate amounts of data. So, the classical AI stuff is pretty good at representing knowledge, but there's not a lot of learning there. There's some work there, and I think, enterprising students should learn things about inductive logic programming, just to throw out one example. But there hasn't been a really good way of blending the worlds of learning and knowledge. And it's critical that we do that, or else, you're constantly reinvent the wheel. You're going to use a massive amount of energy. And the other problem there is you always leave the data set that you're trained on. So if you're in a really narrow stereotyped environment, you might be okay. But as you know, for example, from the driverless car environment, no matter how much data you get, there's always some edge case or corner case, that is not in your training set. And if all you're doing is basically memorizing your training set and you can't get out of that into a new part of what I like to call the training space, or outside the training space, you're in trouble. And the techniques that we have just aren't very good at that. And I've been on this for decades, and I think it's kind of ignored for a while. But like Yoshua Bengio is one of the leaders in deep learning. He sees this now too, as the central problem and challenge is, how do you extrapolate beyond the training set that you've seen? One way is you just keep trying to get a better training set. It doesn't really solve the problem. So the other way is you have to have essentially scientific knowledge in your system so that they can reason about the cases they haven't seen before. And there's a lot of room for research on that question.
No, I really enjoyed your debate with Yoshua Bengio, and I loved it. Like midway through, you said, I'm finding it harder and harder to disagree with you. The debate was over deep learning versus symbol manipulation, and what, is it a hybrid, is it not? And it also seemed very kind of academic in ways, but you wanted to have clarity of language and how we describe what we're working on.
I mean, part of what was interesting about the debate is I think his position has actually moved a lot. So there are talks he gave in 2015 that were basically all about big data. And he was trying to solve natural language with giant amounts of data. And at some point he realized that wasn't really working. And that has pushed him, I think, to a lot of the things that I like. He wants to talk about them in a different way. And so we have a lot of disputes about terminology. We had an interesting dialogue that we wrote together after the debate, which you can find online.
I read that. Yep.
About what counts as deep learning and so forth. But he's actually now focused on a lot of the things that I think are important. Whereas I think the early work in deep learning was just like, let's get a bigger data set and throw more layers at it. And, maybe we'll have a different way of sampling that data. And I don't think those are the kinds of things that are going to get us there. I think he and I still have some disagreements. So I'm much more of a nativist than him. I would like to build in a bit more basic knowledge. But he's like, his student just sent me a paper on the type token distinction, for example, which is like how you distinguish between cell phones in general and my cell phone, or bottles in general, my bottle. It's the kind of question that I like to think about when I have time to do the academic research, and it's ultimately critical because you need to keep records of the individuals in the world and the classes they belong to and so forth. That was not part of the mainstream of deep learning research, but back in my other book, one of my other books, Algebraic Mind in 2001, I was really emphasizing that that's one of the things we need to look at. And Bengio is now moving, I think, to the right set of questions, even if his answers might be a little bit different from mine. And so it was interesting. Like the Bengio of 2015 and me, would have really disagreed about a lot. But the Bengio of 2019, we're coming together, and it's good.
You also made the point in other debates and writings, that most perceived best-in-class AI systems are already hybrid. One example you gave is, OpenAI's Rubik's Cube solver. It still relied on a very well-known deterministic algorithm for solving a cube, in addition to
deterministic and symbolic, right? It was just straight from classical AI.
Yeah.
And they didn't teach it that way, and that was another reason why I've been on their case. If you looked at the blog that they posted, it sounded like a deep learning system learned to solve a Rubik's Cube. And what really happened is the deep learning system learned the motor control. There were some hints there to make it a little bit easier. And the part about actually, which face do I turn when, which is what most human beings think of the word solve, that was, as you say, it was entirely a classical AI thing. And they could have pitched it as, by hybridizing with some classical AI and some cool reinforcement learning stuff, we're able to solve this. But they buried that in like one sentence. I don't think it was even in the blog. And so it was kind of like a sales pitch for what they're doing rather than I think, more balanced look at how what they're doing fits into the larger field. And that bothered me.
All right, so I'm going to turn to questions. We have about 10 minutes left in our time budget. There is a lot, so I'll try to kind of sift through, let's touch on ethical issues. Rose Road wants to know, what are the ethical issues that we need to think about?
I think there's been a lot of interesting stuff written about why we need an ethics in AI, and I think we certainly do. I think that there are actually some practical cognitive problems that need to be solved first before we can get to the juicy stuff. So like I wrote a piece about, in 2012, about driverless cars going off the road in case, these trolley problems and stuff like that. And I actually mildly regret it. It was in the New Yorker. And I mildly regret it because that's not really the problem for driverless cars. The problem for driverless cars is to know whether anybody's going to get harmed. And I always think about Asimov's laws. One of them is like, don't harm people, essentially. Avoid harm to humans. The real question is how do you program a machine to understand what a harm is? And this comes up, for example, in the discrimination stuff that a lot of people, bias that a lot of people are focused on right now and should be focused on. The problem is when we try to solve bias problems without systems that have cognitive underpinnings, that have a conceptual underpinning of what they're trying to do, all we can do is monkey with data in one way or another. So we can add this, or we can notice this counterexample and try to add a Band-Aid here and a Band-Aid there. And it doesn't really work. I mean, we still fundamentally have the same kinds of bias problems that were first noted something like 5 years ago. What you really want to do is have the machine understand the difference between historical trends that we don't want to perpetuate, because sometimes those historical trends are built on bias, and where we want society to go. So if you have a system that is trying to say, who's a good computer programmer, it may note the historical correlation that really there were not a lot of ballerinas that were good computer programmers. But is that causal? It's probably not causal. And having those little pointed shoes is not going to make you a bad programmer. It's just that historically, people were routed in particular ways. And so if you just blindly dredge the data, you just keep reinforcing the very cultural stereotypes that we're trying to change. And so you need systems that actually understand things like gender and social opportunity and what we're trying to achieve. And that becomes actually a technical question in how to build systems that understand the world, even prior to the ethical thing. Eventually, we will get to where those ethical questions are ones we can take action on. So, should we save 2 people versus 1 and all the utilitarian stuff and so forth. But right now, we don't have machines that can recognize that this one's doing harm or not. You could imagine, I could save Facebook from destroying the social fabric of the world if I could put in a cost function that would say, don't do anything in your advertising feed that would cause harm to society. And that would be great. You just put it in. The problem is we don't know how to implement the metric of causes harm to society. There's no framework for doing that yet. If we could, that would be great.
Right. Well, that also, causality is an important element. Again, in the next decade of AI, you talk about a need for systems that include machinery for spatial, physical, psychological, temporal, and causal reasoning. Can you elaborate on that? Like, where are we with respect to all those dimensions?
There's some technical work that's great. Like Allen's time interval stuff allows you to reason about, like, if 2 events happen and Do they overlap in time and so forth? But in general, we're not very good at it. We don't have machines that can do temporal reasoning. Like if you showed a machine a picture of Picasso next to a picture of Julius Caesar, it's not going to be able to sort of work through the chain and say, that can't be a picture of an actual event because Caesar lived a long time before Picasso. Yeah, you could cobble together some specific code to do that particular problem, but you won't find it in general form. I think somewhere, maybe it's in the book or maybe it's a Times op-ed or both, we used an example of, did George Washington own a laptop? And, everybody in this room who at least, grew up in the West and knows who George Washington is, will immediately realize, no, there were no laptops in that time. And it's a sort of trivial bit of temporal reasoning that combines some facts that you already know with some understanding about these relations. We don't really have systems that do that well. Spatial reasoning, we have things that work well at, say, maps and so forth right now. But another example that Ernie Davis and I like, it's really Ernie's example, is a cheese grater. How a cheese grater works. So we can build the spatial representation of a cheese grater into a game engine, and it can figure out the collisions. So you could have a giant cheese grater and then like an airplane that's the size of a phone, and you could figure out, is it going to fit between the holes? So that part of spatial representation is very well done. But the part about spatial reasoning about which way would you want to hold the cheese in order to have the little shavings of the cheese come out, we do not have any framework for that. And there's nothing off the shelf. You could say, I want to build a robot that manipulates things in the world, and it's going to look at these tools and figure out what they do. You could program an answer to that one case, but we don't have a general framework for it. And we don't really have a general framework for causality. We have some math, and Judea Pearl has done some of the famous math, but the math is still missing something about how we understand causal relations of particular entities. Like I have a chapstick in front of me, and I understand how the lid goes on and why it's a little tight at the end. Like, we don't have machines where you could have conversations about that, or where they could use that knowledge in a general form in, working in a home or something like that.
Okay, there's a few more audience questions. Joseph O'Donnell, why didn't the CYC project have more widespread use and application? And that also touches on a bunch of threads you had on Twitter and elsewhere on research directions, what gets you published versus what doesn't, what's popular versus not. And all research is about getting published, therefore, caring about your audience. So what are your thoughts there?
I mean, I could go on for a lot more than 4 minutes on that one, but the short version, in my view, is that the CY system is a bit fragile. It's not completely done, but more importantly, it's not really an end-to-end system. So there's something very appealing about having a system where I can just drop it in, I'll give you pixels, and I'll get output or something like that. And it's really fundamentally a system for representing knowledge and for doing reasoning over that knowledge. But in order to work in a real-world problem, you have to have a system that extracts the knowledge from the scene that it sees or sentences that it types, and then does that reasoning there. So there's like a front end that is not really encapsulated in an easy way, and that makes it hard to work with Psych. Then there's the fact that it's not open source. So, if something that's open source, you get a big community around it. So there are those kinds of issues as well, of it being closed. But I think fundamentally, it's actually very good at a piece of the problem, but it's not a one size fits all solution. And my view is Leonard, who was creating it, was trying to get to the top of the right mountain. He maybe went about it the wrong way, but the field is avoiding the mountain now, and you can't. The mountain he was trying to cross of how do you take essentially the knowledge that a human being would have in the context of reasoning in order to do reasonable things still needs to be solved. The fact that he didn't solve it doesn't mean that we shouldn't be thinking about that problem, but a lot of people don't want to, and I think the field has suffered as a consequence.
All right, so possibly last question. Getting a lot of upvotes, and also mentions another person you have been lately unpleasant to on Twitter, Elon Musk.
Yes.
The fear of AGI by Musk and others overblown, misguided, or what? That's from Maynard Holiday.
I was going to write an essay called Shit Elon Says, or Shit Elon Says About AI. I actually wrote a draft, and then he got in trouble with the 420 stuff, and it seemed like kicking news down, and then I sort of got busy with other things. I think the fundamental problem is that Elon knows a little bit about a lot of things, but his knowledge of AI is not that deep. And so, for example, he's constantly overpromising on the driverless car front. So he just this week said, we're going to have a solution to driverless cars in the next month. And if he does that, I will be astonished, because I know how hard the problem is. I know lots of people working on it. And yes, you can have all kinds of prototypes and so forth, but to really get it to human reliability, which he sort of implied on the state, would be really, really difficult. And then there are other things where I just think he runs his mouth and doesn't know what he's talking about. Like COVID was an example, right? He said that, by the end of April, we'll be basically down to 0 cases. And it was obvious to those of us who read the literature, there was no way that that was going to happen. And so I think he could stand to do a little bit more self-censoring and stick maybe to some areas that he knows better. And, a lot of the things he says about AI, I think, are actually dangerous, is the fundamental problem. So I got really upset when he went on 60 Minutes and said, look, the car is driving and I don't have my hands on it. When in fact, the company policy is you have to have your hands on it, because we know that the system's not reliable enough. So that's dangerous, right? I mean, he's a hero to many people. And so if they say, oh, Elon doesn't have his hands, then they won't either. And then, there are going to be accidents. And a bunch of people have died at Teslas. And, more people would die if there were more of the cars on the road. It's like a relatively small beta test with human beings. And I don't, we're not quite ready for that beta test.
All right. I can't believe how quickly these 45 minutes have blown by. Thank you so much, Gary, for taking the time, enlightening all of us. Hopefully the audience enjoyed your talk.
Thank you very much.
And to close, I want to let everybody know our next RoboChat will be in November. The topic will be predictions for 2021. So please follow us on all the usual suspects social channels. We'll be announcing that soon, the exact date, topics, participants, and so forth. But it will be basically about what to expect in 2021, which might not yet be the post-COVID world, based on the trends that we're seeing. All right. Thank you so much. And that's that for today.
Thank you all. Bye-bye.